And our next speaker, that's Anders Rasmussen. He is a senior principal software developer at Configit. And Anders has been with Configit for quite a long time. And all the gray hairs he have on the head, you can be sure they're only the reason is Configit. Because that's he was our first employee in Configit, and he knows all the information in very detail. And Anders will actually go in and talk about how we can leverage PLM to master product complexity. Anders, welcome to the scene.
Thank you, Shai. What a presentation. Thanks a lot.
So with this, I will hand over to Anders so he can do his presentation.
Thanks. Well, good morning and good afternoon, everyone. My talk today is it's motivated by a question that we've had quite a few times in the history of Configit. So this question, it usually starts with someone pulling us into a whiteboard. And it goes something like this. People start drawing and they're telling us, we have this great PLM system. We're really happy about it. It has our engineering knowledge in it. But PLM is not quite enough. So, and here's the question. Please tell us how you can integrate our PLM system with, and then point to another box and say, a sales configurator. Or maybe they say, other configuration knowledge. If we're really lucky, people would have attended one of these CLM summits and they would ask us, can you tell us how to integrate our PLM system with a CLM system? So that's the question. How do we do that? Now, having been given this question quite a few times, even though it looks like a simple question, and the picture up here is quite simple, what we've come to learn is that there's really not one answer that fits everyone. So my talk today is about how we would address such a question. How would we integrate a PLM system to something else? So what I do if I get a question like that is I'll also grab a pen, I'll go to the whiteboard, and then I'll start asking questions. So the first thing I would ask about, why do you want to integrate your PLM system? So asking that question might seem a little strange. I mean, someone asked me to perform a task for them, and I ask, why? But the interesting thing about this is that usually when the motivation is formulated, it's always the same thing that comes out. But the way it's formulated, that tells us where we start from. Next, we need to know what is success. So how is it that we have to behave? What is the success criteria we have to get to in order to get a successful integration? And finally, knowing those two, the why and the what, we get to the interesting part, which is, so how would we do it? So today is about the why, the what, and the how we can integrate into a PLM system. Let's start with the why. So when people explain why we want to do it, the thing is often a definition of a system's architecture. Now, looking at this picture, it's quite simple, but in reality, a system's architecture is always much more than just two boxes. Usually, we have at least three major systems involved. We have our engineering system, PLM system, where we have bill of materials, engineering logic, etc. We also have a sales system. It could be a CRM system, sales toolbox, dealer management system. But this is where the customers interact with the company in order to buy products. And then we'll have a manufacturing systems. So these are the three major systems we pretty much always see in play. Once again, the picture's never that simple. There's always a lot of other systems sitting around. Some of them, well, there are systems that's been inherited. Some of them are bespoke systems done specifically for this company. It could be add-on systems to the bigger three systems, Excel sheets, whatever. Some of the systems are just there. No one knows where they came from, but we have to keep them alive. The thing about having all these systems is that usually all these systems, they have all a piece of the information that defines the product that we're looking at. The problem often is that these systems, they're disconnected, they're kept in silos. And that means that information in one system is really not used by other systems. So that leads to double maintenance. It's usually contradictory double maintenance. Change management for changing this is really a nightmare, if not outright impossible. And the end result is that the systems, they just don't agree on what the definition of the product is. So I think most of the audience in here, they would know by looking at this that what people are really asking for here is they need a CLM strategy. So what we need to do is we need to connect our disconnected systems, and we need to get the data aligned. So in order to explain how we go about doing that, I'd like to change the picture a little bit. Because this picture we have right now it's extremely systems oriented. And I'd like to change this picture into thinking about intent instead. So when I go to explain what does success look like and how do we do it, let's look at this from a different perspective. So an intent-based view, one good way to look at that is actually the CLM circle. The CLM circle represents configuration intent of our products. So usually we think of one system for a specific intent. I'd like to rock that boat or that thinking a little bit in my presentation here, but at the end of my talk, I will get back to this systems architecture. And this brings us to the what part. So what does success look like? Well, once the systems are integrated, this intent-based view tells us that it doesn't really matter where we store and maintain our data. What matters is that it's aligned. And by having such a systems intent view, we can actually start looking at modeling as a centralized thing. So before moving into this what and how, I'd like to do that by using some color coding. So going forward, when I start to talk about engineering intent, I will color that yellow. Sales intent will be colored blue, manufacturing intent red, and service intent gray. Now, I only have 25 minutes before I get kicked out, so I would have to do this a little short. And that means that I won't go into details with service intent, and I'll be fairly quick about the manufacturing intent. But I will talk about engineering intent, which is where this question started, and I will talk about sales intent. Okay, so going forward with this presentation here, what I will do is I will start looking at intent as being divided into different layers. Now, the success criteria we had was that our intent had to be aligned. So obviously, the intent in these different layers will have to be aligned. Another criteria that we always hear, which is kind of the why we want our intent aligned, is that the companies want to be able to communicate with customers based on sales intent. What does that mean? Well, it means that we have to be able to put a sales configurator on our sales system, driven by sales intent and communicating in sales terms. So that means we want our customers to be able to go into such a configurator, create a configuration which talks about what the customer wants. Not about parts, technical details, but what the customer wants. And the output from this is that we need to be able to get to a bill of material, and routing, and scheduling, etc., so that the shop floor has enough information so we can actually manufacture this configuration that's been ordered by the customers. We don't have to look long at this picture to recognize that this is really the CTO, configure to order flow that people are asking about. Now, we had a few presentations in the previous days where there was some talk about promising things to a customer that could not be delivered. And yesterday, my colleague Jens Ellebeck talked about customer experience. I'm quite sure that promising something to a customer that cannot be delivered is considered bad customer experience. So this is a great motivation for getting things aligned. So in summary, alignment of data across all the intent, that will give us the ability to safely communicate with our customers in the customer's language, in the customer's requirements, and then offer all the products we can deliver. And this will be the basis for faster quoting, accurate pricing, etc. Okay, we've now looked at the why and we've looked at the what. So let's talk about how we can do that. And in the remainder of this talk, I will look at the data required in order to receive, well, to get to these success criteria. Okay, if I want to drive a configurator based on sales intent, the first thing I need is a sales product model. So my product model has all the information I need in order to drive a configurator. In this talk, I will use what I think is a fairly simple product, a bicycle, something we all understand. So imagine that we are a company, we manufacture highly configurable bikes. And let's look at what data we need in order to run a sales configurator where our customers can come in and configure these bikes. Such a product model that has all the data we need for the configurator. The first thing we need in there are sales features. So some might call it choices or options. We call it features. A sales feature is a description of something the customer wants. So maybe if we're selling bikes, a sales feature could be the description of what type of bike we're selling. Is it a racing bike? Is it a mountain bike for having fun in the forest? Is it a bike for commuting to work? We might have some requirements about which user is going to use the bike. How should it be built? Something sturdy, something you can leave in the rain and the snow and it will last forever? Or do you need a super lightweight bike? These are all sales features. Even, for instance, things as the market where my bike is going to be used. That could be something that you want to put in there. I can say from personal experience, I once ordered a bike from a UK web shop. It came to Denmark, and there I learned that apparently in the UK, the front and the rear brakes were reversed from what it is on my market. So you learn, you live, and you learn. The other thing we need, besides just the features here in our product model, is the logic. So this being a sales model should reflect all the sales logic we have. So that means how we want to sell this product. So for instance, if we sell a sports bike, then I'm quite sure we would sell it as an ultralight bike. I'm sure we can manufacture a bike which is heavy and sturdy, but the salespeople know that if we ever sell something as a racing bike and we sell a heavy, sturdy one, customers will be really upset. So this is information we put into our sales product model that talks about how do we want to sell our products. Now the features we have here, those are all sales features. So let's put that in the blue box. This is our sales intent. Also, I'd like to update the CLM circle that we put up now in the upper left corner. So I'll put my features up there as well, and my sales features that go around my sales intent. The product model I have, all the logic about selling it, let's also put that here in the sales box. Okay, so now we have everything we need in order to drive the sales configurator. We have our sales features, the rules, and the product model. But the goal, as you remember, was to get to a bill of material for the specific configuration that we create. Bill of material is usually defined in PLM or PDM systems, in the engineering systems. But you'll notice in this talk, I colored it red for manufacturing. And that's because I think of getting to a unit BOM, which is a specific BOM for an order, that is valid on the shop floor so we can actually manufacture it. Usually bill of materials, they're maintained in engineering systems, PLM systems, PDM systems. So you can think of them as engineering intent, but I've colored it red in my talk. The bike we're selling here, I called it Bike 2000, that will have a bill of material. And what is a bill of material? Well, shortly told, it's a hierarchical structure that is composed of assemblies and parts. So if you look at such a bill of material, the bike could be composed of a gear system assembly and a handlebar assembly. And the gear system could again be composed of other assemblies like the rear derailleur, which is the arm that sits behind when you change gears, and the cassette, which are all the gears and the cogs that sits behind on a bike. So in this box, in this picture, the boxes are assemblies, and the small round ones, those are parts. What I'll do is I'll take all the parts and all the assemblies I have here, and I will put it into my lower box and say this is my foundation for creating a bill of material. Now, at this point, we have no connection whatsoever. We have the sales configurator at the top, we have parts at the bottom, but we have not connected them. So let's do that. The first thing I want to do is I want to make the BOM configurable. And what does that mean? Well, basically it means that the parts we include in the bill of material should be included or excluded based on the configuration. So at this point, I think when we do that, most would say, my parts are not driven just by the customer requirements. They're usually driven by engineering knowledge. So what we'll do now is we'll introduce technical features. So what are technical features? Just like sales features, they're abstractions. They're not parts. There are things that describe how we engineer our product. So for a bike, for instance, a technical feature could be what's called the cog pitch. That's the distance between the cogs or the gears that sits on the cassette at the end. Another technical feature, for instance, could be the cable pull. Cable pull is how much cable is being pulled each time the bike rider changes gear. So those could be good examples of technical features. Now, we don't communicate these features to the customer. That's just important to note. Let's put these technical features in our picture here. So they go into the yellow box. And if you notice, I'll put my technical features around my engineering intent in the CLM circle. Now, usually, there will be much more than just technical and sales features. Usually, we will also have features describing manufacturing. For instance, the plant we're manufacturing things in. There will be features around service, but due to some time limits here, I will go fairly quickly over that. But there will be other features in the system describing manufacturing intent and service intent. So let's just put that up in the CLM circle here. What we've done now is we've created, you can see, a long circle or a circle of features that encapsulates all the different pieces of intent. And this is really a way to create a common language that allows all the different pieces of intent to communicate with each other. Okay, we were about to make the BOM configurable. So right now we introduced the technical features. So how do we do that? Well, we make the BOM configurable by adding what we call selection rules. Some might call it selection conditions, some might call it usage statements. But what they really are is there are links from features to parts. So, for instance, if you look at the rear derailleur assembly, it could be that we pick the first rear derailleur if we have two specific technical features in our configuration. And it could be that we pick the other rear derailleur available if we have two other technical features and a choice of a third one. So when we add these features to the parts, sometimes we might want to reference sales features. So for instance, the market in which the bike is going to be used could be an influencer of which part to choose. So the BOM is made configurable by simply adding all these features and all the logic to the part. And what we end up with here is called a configurable bill of material. Some might call it a super BOM, some might call it 150% BOM. But what it is, it's a BOM that can react to configuration. So when we have a configuration, we can apply it to the super BOM or to the configurable BOM and get a unit BOM. And this was what we were looking for. So let's put all these selection rules into the box that is at the bottom here, because that defines our bill of material. Now let's pay a bit of attention to the assemblies we have over here, the bill of material for our bike. So I'd like to look at the gear system and the handlebar. You can see the bike has a gear system, it has a handlebar assembly in it. We can think of these assemblies as kind of a module, you can say. It's a choice of different parts. They might, in the engineering system, they might have CAD drawings to it, and technical documents, etc. And what we need to do now is that we need to add some engineering logic, you can say, that describe the technical capabilities for these assemblies. And this can be done by introducing what we call a technical module. So a technical module is really like a product model, but it is connected to an assembly. So just like we have a product model for the whole sales model, we can have a product model for an assembly. Technical modules, what they really do is that they define the capabilities, the technical capabilities of the assembly that we're looking at. The first thing we do is that we assign features to the technical modules. And these features, they should be the same features as we use in our assembly. So in other words, the features we used to pick our parts in the gear system should be the same features that we use when we create our gear system technical module. Just like with any other product model or configurable piece of logic, we would like to add some rules. So for the gear system, for instance, it would be very likely that there is some kind of rule tying up the pitch, what's called the cog pitch, the difference in spacing between the gears, and then the cable pull. I could imagine at least that the longer the distance between the gears are, the more cable you have to pull in order to get the arm to move. So that could be an example of something that we need to describe in such a technical module. Let's put these technical modules into the technical part here. So right now we have most of the data we need, but we still have not really connected all the dots here. At the top we have our sales information, sales features, sales product model. That's enough to drive a configurator that allows our customers to talk in sales terms. We've defined our technical modules and technical features so we can engineer our products. We've even tied the technical modules to assemblies, so now we know what the technical capabilities are. We have a configurable bill of material and we have parts and assemblies. But the picture is not quite complete. So what we need to do now is we need to connect the sales part with the engineering part. And this is done fairly simply by making sure that the sales product model includes the technical modules. So what does that mean? Well, basically it means that my sales product model, the Byte 2000 model, will include the technical modules so that when the customer goes in, starts configuring, picking all the sales features, this connection between the sales part and the engineering part will make it possible to extend the feature string so it becomes complete. In other words, now by selecting sales features as a customer, this connection between sales and engineering will give me the sales features. And this is exactly what we need, because once we have a full feature string, we can take that, put it to our configurable bill of material, and that will allow us to select the accurate parts and assemblies we need to manufacture the configuration that the customer has ordered. So now things are connected. But let's go back. This is data. The actual question that people put out was, how do I integrate to my PLM system? So I'll return to the systems architecture we looked at before. And on this picture, in the systems architecture, we have our PLM system. That was what people wanted to integrate to. And we have a CLM system. And the CLM system is where we have all the modeling. It's the features, the rules, etc. In order to do an integration, we need to talk about which system owns what data and what data is sent back and forth. So we see at least 3 common scenarios for doing such an integration between PLM and CLM. The first scenario, it's a scenario where we have a fairly rich PLM system. And in this system, we not just have parts and assemblies, we also already have a configurable bill of material, and we have definition of technical features and these technical modules. So that means if we have a PLM system that can already do a bit of technical modeling in it, what we can do is we can add a CLM system on top of it, representing the sales part, and the integration will thus be to take the technical modules and the technical features, integrate that into the CLM system, and then let the CLM system connect the sales model that's created in the CLM system with the engineering technical modules. So that gives us the full picture that we have to the right. Now sometimes we don't have all that data in the PLM system. So option 2 is when we have a PLM system that has, again, parts and assemblies, and it has a configurable bill of material. So in this case, we can leave the modeling to the CLM tool. So that means we will put all the features, the responsibility of defining the features, both technical and the sales features, into the CLM system. We will do all the modeling of rules, both technical and sales, in the CLM system. The CLM system will connect the sales model with the technical modules, and then we can drive a configuration. If we do that, we would integrate the other way, you can say. We would push the features defined in the CLM system down to the PLM system so that engineers, when they work in the PLM system, can go in and assign these features to the bill of material. And there's a third option, and that's if we start with a PLM system that has just parts and assemblies in it. It, of course, has a lot of other data in it, but for this picture, we're just focusing on parts and assemblies. So here we place the responsibility of everything to do with something we call configurable into the CLM system. And that means it will be the place, the CLM system will be the place where we define our technical features, our sales features, technical modules, sales modules, tie everything together, but also put the configurable bill of material into the CLM system. Now, it's worth noting that at this point in time, Configit ACE, as a CLM system, does not support authoring configurable bill of materials, but there will be a technical session later where Harpreet, my colleague, will talk about the roadmap, and this is one of the items that will be talked about there. So that brings me over to a summary. So we align information in a PLM system, or we do this, please integrate my PLM system with a CLM system question, by first starting to look at our combined product intent. This is what we have in our CLM circle here. The first thing we do is we establish a common language. So we establish a feature language that represents all the different pieces of intent: engineering, sales, also manufacturing and service. And by that, we have a common language that enables all the different pieces of intent to talk to each other. Now, this point is, I think it's important to say that it doesn't really matter where we maintain this feature language. What matters is that it is known to all the different systems that will use it. So this is how we communicate with the intent. The next thing we need to do is we need to pick a scenario. So we need to decide what data lives where. How much data can we have in the PLM system? How much data do we want in the CLM system? And that would ultimately dictate which way the integration goes, what data flows from PLM to CLM or from CLM to PLM. And then finally, of course, we need all the data. So I presented various things that we need in order to get to a successful configure-to-order process. So we need parts and assemblies, we need configurable bill of materials, we need technical features and sales features, we need modeling for both sales and technical intent. And if we have all that, what do we get? Well, what we get is we have the possibility for combining both sales and engineering into one model. And that will give us a number of things. First off, we know things are aligned. Secondly, it allows engineers to work in a modular fashion. So for instance, if we have technical modules associated to assemblies, engineers can go in to the PLM system where they work with the assemblies. They can configure them. They can simulate the bill of material. Once they're happy with it, they can release these modules and we can reuse them. So the gear system for the bike I have up here could have been reused in other product models that also have a similar gear system to them. And last, but most importantly, I would say, we get to a point where we can safely let our customers go into a sales configurator, pick the sales features representing the requirements that the customer has, and let the system figure the rest out. By associating the product model for sales with the technical features, we automatically expand this feature string to full feature string, getting all the technical features involved in the feature string. We can apply that automatically to the configurable bill of material, and we can get to a unit BOM that is accurate and represents the thing that the customer actually ordered. So this is about alignment. We get all the intent put into one system, one view. We make sure that we represent all the data we have for all the different life cycles of our product, and then we make sure that we can support all the different pieces of working with all that data. So after all, that is what CLM is all about. And I think my time is just about up. So with that, I would like to say thank you